Welcome to another episode from the Ed of Ed. Okay, this is my latest little 3D printing radio project. It's a air capacitor for a radio with a little gearbox system. And with this, I can make these little modules to be able to mix and match all kinds of different little experimental radio projects I'm playing around with, mostly crystal radio stuff. And it makes it a lot easier to tune around with without having to deal with the fine finesse of a direct drive, and it eliminates body capacitance, and they're real easy to make. And so I thought I'd show you folks this little project here, and maybe you might be interested in making your own. I have the 3D print files on Thingiverse, and so here I'll give you a show of what this is all about. So if you've ever, experienced dealing with these little variable air capacitors for any little hobby projects where you're just direct driving them, you'd be familiar with how frustrating it can be to use these sometimes on a, maybe trying to tune a circuit that, you have very little control over the little fine value that you need to adjust to. So, and you'll have, troubles with body capacitance and so forth, where if you touch that shaft or go near the capacitor, it'll just throw it all over the place. So the nice thing about this little gearbox system is, you're quite well removed from the air capacitor, and you can just turn that knob with such great relaxed character compared to the direct drive, and really be able to adjust it in a very fine finesse amounts. Here's a quick demo using the capacitors in a radio circuit. Here we have the radio set up, and the capacitors and coils to the furthest left are the QRM or notch filter parts of this radio setup, and they'll basically reject a particular frequency that they're set to. The two devices kind of in the center, the one to the left of that is a barometer, and it's variable inductance, and the one to its right is the capacitor, and that's basically part of the classic tank circuit that basic crystal radio would have. And then the capacitor furthest to the right is a capacitor that basically kind of adjusts the whole thing and the antenna up and down in reference to ground, and it helps a lot in sharpening and the tuning of the circuit and filtering and so forth. And then the little red box to the right, of course, is the little transistor amplifier for taking the signal from the crystal radio and just amplifying it with a little microphone on it in front of it to record the audio that's coming off this radio. So with this radio, you have quite a few knobs to turn, and obviously this is kind of why I came up with this project, to have so many capacitors and to have it modular so I can try different design ideas. So with having 4 capacitors here, I can easily filter out signals I don't want, at least 2 stations at this moment, with the 2 QRM coil capacitors on the left, and then of course the usual tuning circuit in the center there with the variable inductor barometer and the capacitor, and then the capacitor on the right is being able to adjust the tuning a bit better. But with, like, for instance here with this capacitor I'm tuning right now, I can filter out or notch out a particularly strong station and then be able to hear a little bit weaker station kind of in behind all that stuff that I wouldn't have been able to have heard before. And so sometimes when you think your radio isn't really working all that well, it may simply be that you have some really strong stations that are just drowning out everything else, and you can notch or filter out those stations, and everything that's underneath isn't too close to that exact same frequency. You can tease out stations that you could never have heard of before, thanks to being able to use these notch filters. And that's another thing I'll go into in another video here. And then of course there's the convenience of having a variable inductor to be able to tune around. That's really quite nice. And the nice thing about these variable capacitors is it makes life so much easier when you have 4 times the resolution to be able to make these adjustments. So you're not having to use this really super fine touch. It's really hard to not overshoot. Okay, so here's our little gear system for our air capacitor. I'm using FreeCAD 0.21.2 with assembly A2 Plus for assembly module. And you can see in the tree here, the various components, and there can be related constraints. It's a pretty straightforward little design. I have, in this case, a very crude mock-up of the air capacitor. The air cap is mounted on its base with some slots, and that allows me to move the gear up into this other gear on this knob. Let's see if I can make this transparent for you folks to make it a little more clear what's going on here. Let's see here. So what you have is this knob goes into this little couple holes here with a couple different steps to it, and a little clip that holds it in place. And the knob has the gear built into it. And then as this capacitor is moved up and down these slots, it can engage that gear, take out that lash. The gear itself is mounted to the capacitor shaft via this compression hub. I like compression hubs and tapers because people, they first always want to go to just using set screws, and I've always found set screws to work very poorly. They gall the shaft, they don't provide enough force, they'll kind of cock the device that you're trying to mount to that shaft off to one side, ruin the concentricity and so forth. So what I have here is a series of little fingers that are compressed by a taper that's on the compression hub, and that can, clamp down onto that shaft. There's obviously a limit to how much force you can apply. It's plastic and so forth, so you can bully this knob and cause the shaft to be turned in reference to the gear when the capacitor reaches its limits. But as long as you're being a little more light on the finger touch, you're wanting to be finessey about this anyways, not like bully it. It should never be a problem. And the other advantage is you can, take it apart, put it back together again. Maybe the splines might not be as, pliable at that point, but you can readjust things without having that gold spot on, say, the shaft and so forth. Let's see here. What else is there to talk about here that isn't really a big deal here? Let's see here. Oop, wrong way. Yeah, there we go. Okay. So there's a little window here. I don't have the gear and the knob perhaps positioned ideally for this mock-up here, but it's designed so that when you turn past the second turn, this gear starts to appear in this window, and it can tell you that you're starting into that second turn, and then you can look at the second set of graduations on the dial face here, which I don't happen to have in this mock-up, but I'll show it to you when I do the actual assembly. The base itself, it's ergonomic. It's got like a 15-degree angle, so it's a little easier to work with, and has some little slots down here for your nuts, and these are 632 nuts that go slide in there. They press in there a little on the tight side, which is kind of nice, holds it in place, and then a screw that goes in and clamps it all together. There's a bunch of holes in here that I perhaps could have put a little more thought into their positions for possible components you might want to mount back there. It's kind of just a repeating pattern. I wasn't really sure what's going to mount back here other than the QRM coils. You obviously could always change that or just drill new holes yourself. And it's pretty straightforward, just some screws. There are some shim washers that you do have to put in here because of there's some insulators on this cap. I'll show it to you a little later here. This clip holds it in place. A couple screws. It could be simpler to assemble. I guess the one minor hassle is I usually try and avoid parts that require any sort of supports, and obviously this part here is a single 3D print, and so you'll have to enable supports in your printer, and so you'll have to clean out the little bit of flashing that will be allowing this arch to be printed along with these slots and a little bit of a pocket where this gear goes. But I think it's well worth the trade-off. A single part that makes it really easy to assemble, and the alignment of the shaft through these holes and everything isn't an issue and so forth. It's really easy to make. You get a 4:1 ratio for your gear knob, a nice place to mount a graduated dial face, and you eliminate body capacitance and so forth, and you got a nice place to mount some components. So I think from a modular standpoint, it makes for a nice, easy project, and hope you enjoyed this little project. It's real easy to make. Okay, so here I thought I'd do a quick little thing on maybe how you might print some of your stuff. So I happen to have one of my more favorite 3D printer programs, Repeater Host, and here is my faceplate that basically mounts the air capacitor. You can see that it has this arch into it and so forth. Obviously you need to orient the thing right with the face down, and obviously it'll print that way. And then we'll want to do the slicer software. I kind of like sometimes to, on a big part like this where the edges might curl a little bit because of the cooling, heating of everything, I might put a little bit of a brim on there, and that keeps those edges from lifting a little bit. Just, you have to trim it, but it makes it a little bit nicer. And then support type, I will do, I guess, everywheres. And we'll slice it. And, it's kind of one of those things you have to do a little bit of fiddling on what it is you might want to do, and how much you want to endure in the way of supports and so forth. And that's kind of up to you to kind of figure out. I've actually done relatively few supports myself, so I probably could dial them a bit more and learn how to do it better myself. But, you get kind of an idea here, I guess, in this little preview of how those supports might go if you were to choose a simpler, perhaps a little overdone, naive arrangement here. I probably could have done a little better on mine. It was a bit of a bear to trim all that off. It doesn't. It's really kind of hard to show in this graphic how that goes, but you kind of get the idea here that you'll have some extra plastic in there to support all this, and all that you'd have to trim out. What you're trying to do is keep these little support areas to a minimum. So I probably had too much and too close to the edges here. So I guess fiddle with that. That's something I wish I had more advice on, but I don't. So that's kind of basically that part. And I think really the only other part that might be noteworthy to mention would be the knob. The knob here, you can see it's a single part, and we obviously need to orient that. And here, it's a fairly tall thing. Adhesion could be an issue. You don't really need supports. I've got this angle enough to where it just works. You might have to do a little minor sanding, but you can avoid doing supports completely on this guy. The support isn't really needed here either. You can trim it off a little bit, that little bit of plastic that doesn't quite want to stick. At least I've not had any troubles with it. So in the slicer, I would take and turn off the supports, but leave the brim, because I have had troubles with... Okay, so maybe the next thing to explain would be the gear itself, because there's a lot of detail here with the teeth and the splines. Fingers, I would definitely recommend the highest resolution that you can do. It's once again not a terribly large part, and detail is definitely more important here. I would set adhesion type to none, and the brim, I wouldn't want the brim, because then you'd have to clean out all those little spots in the teeth, and adhesion doesn't seem to be really a problem for this guy. And it's pretty straightforward. Once again, I think PLA works fine. It's, kind of a brittle plastic, but the little bit of travel that these fingers have to go and endure, it seems to be working fine. I haven't had any troubles with the plastic breaking or anything like that. And then the hub itself is very straightforward, very simple little part. I'd recommend having the taper on the outside. Once again, you want the highest resolution you can get. And it's a very tiny part, so it certainly doesn't cost you much to print at a high resolution, and it keeps those little steps from hanging up on the fingers and so forth and compressing it. And I think everything else is pretty straightforward. So let's go on to the build of this guy. Okay, so now they got a big pile of parts. Let's see if I can build a whole bunch of these air capacitor gear modules here, and have me a whole bunch of little capacitor modules that I can then mix and match with various other components to produce all kinds of interesting experimental radio projects. And so the first thing I kind of need is these little brass inserts that you melt into the plastic to produce some really nice threaded for attaching the gear to the shaft with the compression hub. And so I set my soldering iron to kind of a moderate temperature, a little over like 450 degrees seems to work pretty well. I've seen some people when they melt these things in there, the PLA plastic is smoking and melting really fast, and I've experimented with maybe temperatures are a little too low. It gives you a little more time to kind of melt them in place. What I find is that once I've kind of melted them in place, I like to push them against a heat sink to flatten them up against that face and then suck that heat out so that you don't further distress the plastic any more than you need to, and it seems to make a pretty good bond. Afterwards, I'll chase the threads with a tap, and in order to clean out any little plastic that got up in there and distortion the brass from the heating. And right around this time, I started doing my little factory of radio capacitor assembly. I'd gotten a new SDR radio, and of course had to play this SDR radio while building all these components together, so that's why you're hearing all this ham radio talk in the background. So after the screw melt-in nut inserts are put in the gears, it's time to put that compression hub into place. And I initially just kind of lightly put the screws in without the hub actually compressing. And then I position the capacitor so it's fully meshed. And then I push that gear onto the hub, onto the shaft, and you'll want to make certain that your 3D print is such that the gear and hub just lightly slide onto that shaft. There's a little bit of resistance. If it's too loose, then it might not be enough tightness, as it were, for the compression fingers to actually clamp down on the shaft. So it's kind of one thing to kind of be aware of, that you probably do want that to be a little bit tight, sliding on that shaft. And then you just systematically go lightly around this compression hub with the screws, lightly tightening to make certain that it's all going on true and flush to the surface, and that it's not caulking off to one side and so forth, and that you're not tightening one side too much and bowing it over or anything like that. And just kind of lightly go around and around and evenly tighten it down to its a nice, reasonable, light finger tightness, and it compresses that hub straight down onto the surface of the gear. You'll also notice I'm holding onto the gear itself and not the capacitor, so that position alignment that I was showing earlier, that the meshed rotor vanes are in line with the gear. That it gives you the best alignment for later on when it's actually assembled into the frame. And you just kind of check that everything's kind of aligned. And of course, it's another evening. You get a few hours after work each evening to fiddle with this stuff. And now it's putting some 632 nuts into these slots on the base plate to assemble these little frames that the whole capacitor mounts onto as little modules. And just a couple of 632 screws. I don't remember the exact length. I think they're like half-inch long 632 screws. While I'm assembling this guy, I think I'll mention to you that I'm doing all kinds of other radio projects, components and so forth, so stay tuned to this channel as I develop and produce these things and show them to you folks. I think this project is probably the most parts I've ever printed for a particular project. I mean, this is quite a factory, making 6 of these air capacitors plus the prototype. It gets to be quite an impressive pile of components, and it's just so easy to do. You just once you got it all designed and the print G-code files are all done, you just hit the button on the 3D printer and bazam, 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 you get all these parts very quickly. Makes life, other than deburring the plastic or the little bit of support material, it's super easy to make all these things. And the next thing is, of course, stripping and cutting wires to connect all these guys. The capacitor itself there's 4 contacts at the bottom, and they're all bonded together for the stator side. The type of connectors I'm using are Ampex plugs, the type that are used in the old hard drives, and using the females for the component devices like the capacitors and coils and so forth, and for the interconnecting wires that I use to connect all these devices together. That's always a male connector. I have to bend the these leads down because the capacitor is going to be mounted to the frame at its base. The one has to unfortunately snip off because it interferes with the slotted mount point. And then the other awkward thing is because there's some like fiber insulation on the ends of this yoke frame that forms the chassis, as it were, of the capacitor. They stick out a little bit, and if you were to compress them onto the frame with the slots, you might stress and pop those insulators off of the frame of the capacitor. So you need a little bit of a shim spacer, and so what I've done is I've taken some, I believe, 1032 washers and simply ground one face off so that the holes of the washers align with the holes for the capacitor, which is simply 632 screws. And then I used Scotch tape to hold those washers in place to make life a lot easier in installing the capacitor onto its little slot mount. And just a matter of initially getting that gear kind of roughly in place and putting all the screws in place and getting it lightly held in place. Then the next thing is just before you completely also tighten the screws, you want to do the last minute adjustment to where that gear is going to be in relation to the capacitor vanes. Say if the vanes are completely open or closed, you want to make sure you have that pointer pointed in the direction you want. Yeah, take off the cellophane tape before you tighten it down completely. In a few instances, after I found the very best location I could for the pointer versus the gear and capacitor vane location, I would find that maybe the pointer would be ever so slightly off from one side or the other of the 0 tick mark at the top, and mostly what I wound up doing is just simply bullying the knob just a little bit and forcing the shaft to slip a little bit on with the gear. Obviously, if you hear crunching sounds, you're probably pushing it too far, but I was able to find that every time I was able to, some slipped a little bit more easily than others, and I didn't damage anything. But last but not least, take one of the screws off and put the ring lug screw connector for the other side of the capacitor connection, and I'd put it on its side so that washer underneath doesn't fall off. It could be a steel screw or a brass screw if you want a little bit less resistance, but and then at the end there you might consider putting in on some labels. And then after quite a bit of factory work, I have quite a few capacitors to play with for all kinds of various experiments. I can mix and match these guys with all kinds of designs. Really super easy to make, highly satisfying, and there's room in the back there to mount components and so forth. And yeah, so it's maybe a bit on the bulky side, and it's not a permanent, obviously, radio circuit installation in this case. It's really meant for experiments, but I think for little hobbyists, do-it-yourself, playing around, it's a nice solution. And so there you are, a whole bunch of capacitors, and thanks for watching.